The modern jetliner is one of the most complex machines ever built. Determining how and when to launch a new airplane and which new technologies to include is one of the great challenges of the aerospace business.
When you're building a new aircraft, it's a really huge undertaking, and it's so much is riding on it. The company's whole future is at stake.
In 2000, Boeing had a decision to make.
We set aside a small team and literally locked them up in a room and said, we need you to start thinking about a brand new airplane.
We got to understand that.
Boeing called it the Sonic Cruiser.
So there was this really enthusiastic group of engineers at Boeing that were working on the Sonic Cruiser, like their life depended on it. It was the coolest thing at Boeing.
It would be a dramatic departure from the design of existing commercial jets. It would have a delta wing, rear-mounted engines, 2 small canards near the front, and a fuselage made of a synthetic material, not metal. Built for speed, it would fly just below the speed of sound.
The shape of the Sonic Cruiser was like virtually nothing that had been seen before. It was a thing of beauty.
It just caught everybody's imagination. And what the airlines were looking at were 2 things. One is the 20% faster gave the passenger what they wanted, right? You get someplace quicker. The other thing was the airplane flies 20% faster. In theory, you should need 20% less of them.
The problem is that once you nudge the speed up to that level, it becomes a gas guzzler. There's nothing you can do about it.
And one consistent concern of every airline is the cost of fuel.
It's not just the fact that fuel cost is higher, but it's the fact that it's so variable that constitutes a huge risk to the airlines. You just can't foresee exactly what's going to happen.
The day after the 9/11 tragedy, there was a meeting in Seattle for aerospace professionals. Everybody was shell-shocked by the events of the previous day, but there was almost a recognition that the supersonic era was suddenly over with, and we were looking at a much more austere future.
After 9/11, everything changed. The price of oil went through the roof. Our customers told us they wanted an airplane that went long range, burned much less fuel, and for all of that, they'd be willing to sacrifice all the performance we had, the speed, and some of the other things.
Although it was a sad kind of acknowledgement, really, of the realities of life, Boeing got on with it, you know. Hey, the market's spoken, we know what they want, let's go and do it.
Boeing would call its new plane the 787 Dreamliner. It would travel at conventional speeds, but it would incorporate many of the advanced technologies intended for the Sonic Cruiser. What would set this new plane apart from every commercial jet that had preceded it would be the very material used to construct it. Boeing's 787 Dreamliner would not be made out of metal, but out of fiber-reinforced plastic. It is an advanced variation of composite, the kind of material commonly used in small consumer products, such as tennis rackets and bike helmets. It's made of lightweight carbon fibers, fabricated into thin layers and infused with a glue. The combination is much stronger than either ingredient on its own, 10 times stronger than its weight in steel. Companies around the world were chosen to engineer and manufacture large sections. The most ambitious innovation Boeing and its partners introduced was the process of spooling long strips of carbon fiber onto what are essentially enormous robotic tape dispensers that lay the material down in precise, complex patterns. It takes the shape of specific parts, like a wing or a fuselage, and then the huge sections are transferred into a massive sealed chamber called an autoclave, where they are hardened under heat and pressure.
If you think about a fuselage barrel,
In a plane like a 787, there's as many as 9 people sitting across in a row. So it's a pretty wide object. Imagine that I have to cure it under heat and pressure. It's like, how would I describe that? Imagine putting an airplane in an oven.
Out of these giant autoclaves come pre-built sections of the plane that once would have required hundreds of aluminum sheets, tens of thousands of rivets, and countless man-hours to assemble.
If you look at the way we built the 707 back in the 50s, and you look at the way we build a 787, it is amazingly different. It is off the charts different.
By the end of 2009, a finished Dreamliner was ready for its first flight.
From the time it started as something on a piece of paper to an actual airplane, it's 5, 6 years sometimes of people's lives that they've put into that one single thing. The culmination of all that pride and ownership that you have, to see the airplane come off the ground, it's one of the most exciting things that you'll ever experience.